Hey guys, so I know a lot of you had a hard time with seeing how the H plus ion is transferred for Bronsted-Lowry acids and bases. So I'm using this video to draw you more pictures to kind of show you better what I was trying to get at in class. So let's get to it. So here again, the Bronsted-Lowry definition for acids is that it donates an H plus ion. And the Bronsted-Lowry definition for bases is that the base accepts the H plus ion. So here I have an example. I'm going to show you what's not correct first, and then I'll show you how it looks like correct second. So I have hydrochloric acid, HCl, reacting with a blue blob. Yes, I love blobs. And if the acid was just defined as being a hydrogen transfer instead of an H plus ion, your products would look like, let's make it, you would look like you have the H go onto the blue blob. So you would have H and then blue blob, and then your Cl would just be by itself, so plus Cl. So if the acid was just a hydrogen atom, this is what it would look like. The hydrogen would just plop onto the blue blob, and you would have H blue blob plus chlorine by itself. But that is not correct. Acids are not defined as being a hydrogen atom. They're defined as being a proton, H plus ion. So the way that is correct is if you have the H plus proton, so this HCl really breaks into ions of H plus and Cl minus. So the H plus is going to go onto the blue blob. And so your product will be H plus and blue blob. Plus, because your positive hydrogen has left your chlorine, the chlorine is left with its negative charge. Originally, the plus and the Cl minus, they canceled each other out, so this was a neutral compound. It looks just like HCl, but I know that it's really H plus and Cl minus together. That all goes back to our redox unit, because you have two different things bonded. Chlorine likes to have a -1 oxidation number, and hydrogen likes to have a +1 oxidation number. So this is the correct way of showing the acid ion transfer, is that the whole H and the plus goes onto the blue blob. And so you're left over with Cl minus by itself. So that was the point that I was trying to make in class. And let's just do some practice problems with something other than blue blobs, as much as I love blobs. Okay, so for my first example, I'm going to do the one that we were working on in class, which is hydrochloric acid reacts with water. And I want to figure out what the products are together instead of just looking at what the products are on the pole. So we know that HCl is the acid because you can just check. I know they both have H first, like water has an H in front and HCl has an H in front. But if you check your reference table and see, here we have HCl, hydrochloric acid. So HCl is really the acid, water just happens to have an H in front also, but water is usually the neutral guy, so yeah. So let's go back to here. Alright, so we know HCl is the acid because we double checked our reference table and it has that H in front. And so water is going to act as a kind of base in this scenario because it's next to a strong acid, so it's just gonna, it doesn't want to be a base, but it's going to be a base because it has to be, since HCl is forcing it to be. It's kind of like, if I think of like a human example, you know, like if you have someone that's like incredibly nice in your life, and let's say like you're a pretty neutral person, but because they're incredibly nice, they like bring out a certain side in you, okay? That would be my best way of explaining that. So yeah, let's just predict what the products are. So we know that the acid is going to transfer H+. So this acid, even though you don't see the charges of the ions, you know that hydrogen, and we could go back to our reference table really quick, hydrogen can take on a positive or a negative charge, but because it is with chlorine, it is going to take on, chlorine likes to gain 1 electron, so chlorine is going to be -1, and hydrogen is going to be +1. So, the ions here are going to be really H+ and Cl-. So our base water is going to get the whole H+ ion. So what do you think the product will look like when it gets an H and it's plus? It will be H3O+. And left alone will be the chloride, Cl-. Let's try another example. Okay, so I have a new acid and water again. And if we look at our reference table, you will see that phosphoric acid, H3PO4, is listed right under table K. So H3PO4, phosphoric acid, is our acid, which again forces water to be the base. So in predicting what our products will look like, we know that the H3PO4 is going to give up an H+. So that is going to, just one of them, just one H+ is going to go on to water. So that is going to form H3O+ again. Remember that it is getting an H, so it's H, it goes from H2O to H3O. It's gaining 1 H, and it's gaining 1+, so it's going from neutral to +1. So what will H3PO4 look like without an H+? So if you lost 1 H off of this molecule, then you're going to be H2PO4. And don't forget, you also lost 1+. Before it was neutral. I added the little plus there to visually show that you were transferring an H+. But it started off as just H3PO4. So it's just a neutral acid. So if it starts off neutral and it loses a plus, then its new charge is going to be minus. Alright, let's try another one. Okay, so I now have H2SO4 and NH3. So I am not totally sure which one's the acid. I see that this has an H in front, so this one's probably the acid. But I might want to double check because NH3 also has H's in it. So easy, quickly double check your reference table. If it will open. Oh my gosh. So on my reference table, I see H2SO4 is sulfuric acid, so that one's our acid, and I see NH3 listed as a base. So I know for certain that my H2SO4 is the acid, and my NH3 has to be the base. So that means that the acid is giving an H+ up. So I'm gonna just put a little plus here, so again I remember it's giving an H+. And that's gonna go on to the base. So if NH3 gains an H+, what will that look like? So I'm going to show, well, first if it gains an H, it goes from 3 H's to 4 H's. And we have to remember it's also gaining the plus, the positive charge, so it's going from a neutral NH3 to a positive NH3. In terms of what the other ion looks like, so our H2SO4 lost a proton, an H+. So let's just check out. Originally it just looked like this. It was just H2SO4 neutral. So if it loses an H+, well, let's just start off with one less H. So now it has H1SO4. And it also lost the positive, so now it's going to be negative. It only lost one positive. Okay. So to summarize, the acid is always giving an H+ onto the base. And the base is always accepting the H+ from the acid. So that is our new definition of acids and bases. The acid donates the H+, the base accepts the H+.